In this lecture, we'll be building the TPOT model for predicting the insurance premiums, or you can say insurance charges. So the set of steps we will be taking is, so step one is to import the data set. Then step two is to visualize the raw data. Then step three is to encode the categorical features. And then we will be performing some data analysis by doing different kind of plots on the data. And then we'll scale the data. Then, as an approach, we want to compare TPOT to our ensemble model. So first we need to build our ensemble models, find the RMSEs, which is root mean squared error, accuracy scores. Then we would check whether we have TPOT installed. If not, we're going to go ahead and make the installation. Step 8, we're going to go ahead and build the TPOT model, make the predictions using the TPOT, and finally, we should be able to compare our TPOT model with the ensemble model as well as the stacked model. So let's start with importing our dataset. I'm importing the package pandas, and then my file name is insurance.csv. And if I do pd.readcsv and pass the file name, I got the data in my data frame called df insurance. Let's do df.head, and these are the columns: age, sex, BMI, children, smoker, region, and charges. So it appears BMI and charges are numerical features, while the other ones, and age is also, but sex and BMI are not, as well as smoker region, for which we would need to do the categorical encoding. Then we basically can do our df.info, which would give us an idea of the data types. We can see obviously age is integer, children is integer, and followed by charges is float, rest are objects. Now if I do the describe, here the mean, standard deviation, and min and max values for these attributes. So it appears that number of charges are 1338, the mean value is 13,217, 270, and then we have the max value somewhere around going around 63,770. Likewise, the age of the children is between 1 to 5, and these are the values for BMI, and respective of the ages vary between min value 18 to 64. Let's do the shape of our data frame. I'm going to do is df.shape 0, which would give us a number of rows, and df.shape 1, which is number of columns. We have 1338 rows and 7 columns. All right, so the next is basically checking for the missing values. For that, we're using df.isNull.sum, and we see there are no null values, so we are good, no imputation required. We can go ahead and do the duplication check. For that, we can use a standard method called drop duplicates. So we're gonna check if there are duplicates, then drop them. So df.drop duplicates, and then filter the data if any duplicated rows exist. And no, we cannot see any duplicated rows, so which is fine. Then we're gonna do the correlation by simply calling the correlation function our data frame, and let's do the visualization. So for that, we're gonna simply create a function called plot correlation matrix, pass the data, and data.correlation should give us a correlation. Rest is a boilerplate code. I'm not going to go into that because that's not the objective of this course. So you can tune into my previous lectures where we have done sample correlation exercise. So basically we are setting the correlation bar over here, peg.correlation bar, and setting x ticks and y ticks by giving the length from the range of length of correlation columns. And finally, we are calling a plot for correlation matrix. So we can see this is our correlation matrix. The color yellow indicates there is a one-to-one relation for those attributes. So age versus age is yellow. That means it's 1:1 is the same attribute. It's highly correlated. But then it should not be treated as actual correlation, but the only correlation should be treated as the dark color, the dark complex. So if I can see this purple box compared to the children versus the BMI, there is a strong correlation. Likewise, the charges has correlation with the children, as well as we can see other attributes as well where there is correlation exist, right? So now that we have done the correlation matrix, we're going to go ahead and keep visualizing our data, and then we have to do the scaling of data before we start doing the implementation of our ensemble model. So stay tuned for more lectures. Thanks for joining. I'm going to see you in the next lecture.